Let's start by talking about linear equations, then linear inequalities, and then we'll work in a word problem to apply this to. When we're talking about linear equations, there are actually three types of equations we could come across. We could come across a conditional equation. This is the type we usually see. This has a specific solution like x equals 5 or x equals -10. The next possibility is we could be working with something that's a contradiction. A contradiction is an equation that actually does not have a solution. So it looks like an equation. We could use the normal sort of methods to solve, but what we'll find is the variables will disappear and we'll be left with a false statement. That's an indication that there's no solution. The third possibility is we might be dealing with an identity. An identity is an equation that is actually true for any value that we would put in for x. And so in that case, kind of a similar situation. We could solve by the standard methods, and then the variables often drop out, and we're left with a true statement. If that statement is true, then that indicates that we have infinitely many solutions, we could say, or all real numbers as a solution. Okay, so I think you have a lot of experience with solving for an equation with one variable. One example that I think sometimes we can use a reminder on is if we have an equation that has some fractions involved. The strategy I like to use for an example like this one that has some fractions is we can take away the fractions by multiplying by the least common denominator. So if you look at this example, we have two denominators. We would like to multiply by one number that would allow us to divide by both of these denominators, or cancel them out, I guess, so that we don't have any fractions, and then solve the rest of the equation as we normally would. So 9 and 6, think about what's a number that both 9 and 6 divide into evenly. Keep in mind this is a bigger number. So 3 would be the greatest common factor. That's not what we're looking for. We're looking for the least common multiple, or the least common denominator. Have you figured it out? So for these two denominators, the least common denominator this time, I think, would be 18. 18 is a number that 9 divides into, and 18 is also a number that 6 divides into evenly. Now this is the least common denominator, so could you have found others? Absolutely. This is the smallest number that you could use that would work. Okay, so we're going to multiply everything in the whole equation by 18 to keep it equal on both sides. We want to make sure we multiply each term, even the ones that aren't fractions, like this 8. So I'm going to multiply everything by 18. Now I'm going to write this out just so that I can demonstrate what we're doing here, but you could probably do some of this in your head. Okay, and keep in mind, anytime you multiply by a number, that number is always in the numerator. So if you need to think of it as 18 over 1, you can do that. Alright, so 18 times 8. I have this written down somewhere. I'm not doing this one in my head, but it should come out to 144. When we multiply 18 times 2/9, 9 divides into 18 2 times. 2 times 2 times x becomes 4x. On this side, 6 divides into 18 3 times. 3 times 5 would be 15. So just doing that as a first step allows us to get an equation that maybe we're a little more comfortable with, and we can continue solving from there. We're just solving for x, so I'm going to continue by subtracting 144 from both sides. That's going to give me negative 129. Oops. And then I'm going to divide both sides by -4. A negative divided by a negative becomes a positive. And you could represent your solution here in lots of different ways. You could leave it as a fraction if you like, 129 over 4. Or if you want to rewrite that as a decimal, this would be 32 1/4. So you could actually do a mixed fraction or a decimal, whichever you prefer. Okay, great. So this is a linear equation, right? We solved with an equal sign. And there are lots of examples in your book that you can use to practice this if you need more practice. We're going to move on to the next section, which is somewhat similar, but now we're using an inequality. An inequality would be a less than, greater than, less than or equal to, or greater than or equal to. So the only real difference between an inequality and an equation, in an equation we're going to get one, possibly two or three answers. In an inequality we're going to get a whole range of answers, right? So we can no longer list out the individual numbers that can satisfy our equation. We have a whole continuum of numbers that satisfy our equation. So one of the big differences is that we're going to write our solution using interval notation because of that. The other big difference is that unlike an equation, for an inequality, when we multiply or divide by a negative, remember we're going to flip or reverse the inequality symbol. So if it was a less than, it becomes a greater than, and vice versa. There are lots of examples that we could look at for an inequality. I think you have some experience with these probably already. So I chose to do one that's a double inequality so you could see what that looks like. The double inequality is actually two inequalities written together as an and, right? So that satisfies both inequalities at the same time. And so you could sort of cover this up. These two parts on the left would be one inequality, and then these two parts on the right would be the second inequality. So if you chose, you could write out these two parts separately and solve them separately and reunite your answer at the end when you use your interval notation. Or you can solve this as a three-sided equation and do everything that you need to do to all three sides. I'm going to solve it today as a three-sided equation. So my goal, if this is a double inequality, is to get the variable by itself in the middle. So working to that end, I'm going to subtract 3 from all three sides. That'll give me -6 is less than or equal to -2x in the middle, which is less than or equal to 6. And then, just like I would solving an equation, I'm going to divide by -2, again on all three sides. This is when hopefully a little reminder goes off in your head. Remember we said if we multiply or divide by a negative, we're going to reverse the inequality. The same is true for a double inequality. That applies here also. So instead of less thans now, or less than or equal to's, now I'm going to have greater than or equal to's. Okay, so this is my solution, but I would like to write it in a little bit different format. I always like to point out if you flip when you're doing a double inequality, you know, when you start out it goes from smallest up to largest, but in the process of solving, if we flip, now we are starting actually from largest down to smallest. So just maybe take note of that. If you want, you can write it in reverse, kind of like a mirror image. So this inequality we have here is actually the same if we were to flip it around and write it from smallest to largest. So from smallest to largest, -3 is the smallest, and it's less than x. We kind of read it backwards, which is, or less than or equal to, which is also less than or equal to 3. So these two are actually the same They're just written backwards. And you might want it smallest to largest, because if you're going to use a number line to write your interval notation, this would line up best with the number line. So we can use our number line again as our visual aid. Notice X is in between, smaller than 3, and at the same time greater than -3. So these sort of join. They don't cross each other, they join each other because it's an and. The equals bar underneath tells us that -3 and +3 are included in the solution. So our final answer, we're going from -3 to 3. And because we're including the endpoints, we'll want to use the square brackets. Okay, so that gives you a little bit of an idea of an inequality. So there are, those key parts to remember when to flip or reverse the inequality symbol. And also the interval notation is included as part of the solution. Those are two things that are important not to miss. Okay, last I thought we would add on a quick word problem. Sometimes, even though solving the equation is the simple part, but where this really becomes useful is the idea of a word problem or some kind of applied problem. So here's a simple example. This is from 1.5. It's number 49. It has to do with the dimensions of a soccer field. It says the width of the soccer field recommended for players under the age of 12 is 35 yards less than the length. The perimeter of the field is 330 yards, and we're in charge of finding the dimensions of the field. Okay, so you could do this in a couple of different ways. For this particular type of problem, I like to use W for the width and L for the length. It is a good idea to set up variables for things that you're being asked to find, right? A variable represents an unknown. I don't know the dimensions of the field. I need to know the width and I need to know the length. So I need a variable for those. Now you may use two variables or you may use one variable and write the second amount in terms of the other variable. Okay, so you have a couple of options. I like to use two variables for this type of problem, and I like to take the first sentence and basically translate it almost exactly. So here are the important parts, right? The width of the soccer field, blah, 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 in between, is 35 yards less than the length. Okay, so directly, if I directly translate that, I have the width, which I'm using W to represent that, is my equals. 35 yards less than means I'm going to subtract 35 from what is listed next, which is the length. So the length minus 35. Okay, and I'm also told that the perimeter is 330 yards. If you know anything about soccer, you know that the field is rectangular in shape. So you have a couple of options at this point as well. You can either draw a picture or use a formula. I like to draw the picture. I'm a very visual person. Okay, so here's my length, because it's the longer side. Of course, here's my width. So I'm going to use L for the length for this problem. And instead of using W for the width, I'm going to use L minus 35. Okay, and I'm going to put that on all four sides. The perimeter, oops, I smudged. The perimeter is the sum of all four sides. And I know the perimeter is 330 yards. So I can add all of those things up. I can add up the length minus 35, the second length, and the second width. Length minus 35, and those must add up to 330. And then I have an equation I can solve. Okay, so let's do that. We can count out how many lengths we have. We have 4 of those. Negative 35 and negative 35 make negative 70. And I'm solving for L. I can add 70 to both sides. And I can divide by 4. It looks like my length is 100. Remember, my width is the length minus 35. So 100 minus 35 would be 65. And if I go all the way back to the top, remember my measurements here were in yards. So my length must be 100 yards and my width must be 65 yards. Okay, so this is one way that you could solve this problem. A very important first step was when we set up our variables. W to represent the width, L to represent the length. We used some keywords for translating, and we used a picture. Just to give you another alternative, I won't do the whole problem, but you could have also used the equation for a perimeter of a rectangle. The perimeter would be 2 times the length plus 2 times the width. And you could have used our expression for the width up here at the top and substituted for W. Put an L minus 35 where the W is and worked it out the same way and got the same answer. Alright, well, thank you very much. Good luck with your solving an equation and inequality and a few word problems mixed in.